And Ron, did you realize your name backward is Nor?
Okay, we're ready.
I think we're ready, and I'm not. I'm not on screen just as well. The children may be watching. You click up. My name's Ronnie Heron. I'm vice president of a great club, and I got some great friends around me. And you can't see me this week. It's my turn for everything to screw up. Welcome aboard, the members of the board and the hardcore supporters of the Central Coasts of Southern California's longtime astronomy telescope astrophysics club, your Santa Barbara astronomical unit. I call it 93 million miles of fun in the sun, although it varies a little bit. It's the SBAU Astro Hour, and it's number 189, a weekly online blog using Zoom, where we talk to each other, having a lot of fun every week. This is number 190. That's going on their fourth year in about 4 or 5 months. And we get into some hardcore stuff. I'll introduce you to the guys here in a minute. You just won't be able to see my ugly mug just as well. We're headquartered at the Museum of Natural History up behind the museum in Santa Barbara, California. And this week we are going to talk about the wintertime constellations, familiar, coming back, rising early. What to see during dusk. The moon is about 9% lit. Some features may be viewable due to earth shine. First quarter dead ahead. Check out that Valles Alpus on the moon surface. Chinese named comet Shan is coming to our night sky. Be able to see it without a telescope. Cooler and smaller than our sun. Second most distant star from us, it's Barnard's. We're going to talk about it. Just 6 light years away. We got a great 2001 Space Odyssey type picture lined up, 3 bodies in a row. Supernovas and very distant galaxies that are gravitational lenses or lens so that it helps us determine the true distance. Plus, after 12 years rolling around on Mars, the Curiosity rover for NASA has a hole in its tire. Let me introduce you to the guy on the left of my screen, our beloved president, Jerry Wilson. Jerry
Good morning.
He's the commander, married to Pat Forgy, and has been in charge for about 7 or 8 years. Chuck McPartlin is in front of the Ukraine flag again. Pat McPartlin, the merchandise manager, is his wife, also in charge of the treasury. And Chuck is one outrageously incredible outreach coordinator. We have Bruce Murdoch on screen, longtime helper, supporter, expert, man that I learn a lot from. Also happens to be president of the Santa Barbara Theater Organ Society. Bruce was there at the Friday meeting up front, and he's married to Bonnie. And I guess he'll be helping out one of our speakers on December. We have the in-house people. Hey, we got Tom Whittemore on board, editor of SBAU's incredible newsletter. Also, a witty guy. I call it the Whittemore wit. You have a friend named Conan, I understand, right? What's going on with this man?
Yeah, he's taken a desk job recently.
Who is it?
He's now known as Conan the Librarian.
Okay. All right. Well, you won't be able to see me, but you'll see everything else. Is our Tim Crawford, who's an expert.
Howdy.
Guy I learned a lot from. He's been married to Karen, or at least they're starting to get very serious about each other. And we start the week every Monday morning, 11 to noon, with Jerry's forwarded silly science cartoons and thought provokers on screen. And here they come. Oh, now this is a new one. I haven't seen this. You're going to have to enlarge it. 2 women are talking, one at a bar at the corner, and one says, "My doctor told me to accessorize and buy nice shoes." And the other says, "I'm pretty sure he said to exercise and eat the right foods." Okay.
Is this bigger?
Yes.
Okay.
Okay, what's the tie into science? Is anything going on there? I guess medicine, right?
No, nothing. It was just communication error.
Well, I only got 4 from you. I got janitor, side hustle, and recipe. You want to go? Here we go. This is the giant killer robot being put together. It's on tank tracks, and they're about to test it. And the guy says, "Hey, wait a minute, who's there? Oh my God, Mitch, the janitor." Well, our first test run has just gotten a little more interesting. There goes Mitch, the janitor, about to be taken apart limb by limb. Here's a recipe for making a new planet. This is taking pieces of moons in our solar system and getting something Mars size. Here's what it says. Scientists now think the 5 bigger outer solar system moons, the big ones, actually just ingredients. Was supposed to combine them to create a single Mars-sized planet that's cooler than any of them. You got sulfur from Io, although that'd make it a little warmer, I think. Cool oceans from Europa, hydrocarbons, your methane from Titan, and Ganymede and Callisto, the filler, lots of ice. There it is, our Frankenstein planet. That's a good one. I like that one. All right, this one is labeled Side Hustle. Apparently some terrible manufacturers of telescopes. Well, I'll read it here. Astronomy news. The International Astronomical Union has finally banned beam slitters. Not slitters, splitters. They split the beams. Why? Optical devices used by scientists to embezzle light from the instruments and turn simple starlight into energy producing solar panel energy? I don't think so. But there it is.
Be microwatts.
What?
It would be microwatts.
Yes,
You wouldn't get much, would you?
not a lot.
The more distant. All right, here's another Carl Sagan epigram. I've often thought this myself. You know, the universe is a pretty big place. If it's just us, seems like an awful waste of space, doesn't it? I really have thought that. Are we it?
That's it. That's all four.
Okay, well done. Gets us in a great mood. Had our witticism. Now we're gonna take on the night sky and the coming comet with a Chinese
Yeah.
name. We had a grand time Friday night, everybody. Thank you for showing up and taking part. That was pretty good talk from that young man. First one he's ever given
Was excellent.
on micro
We're
stuff.
very well informed.
Yeah.
Yeah, I had to say,
And the
you know,
experiment he's describing is a very clever experiment. Try to quantize what isn't there.
well, wait till you hear who we have on February. It's going to take us deep into a 1 mile deep mine in the Black Hills of South Dakota, where they're doing WIMP experiments trying to nail down dark matter.
Is
Okay.
that Harry Nelson's thing from UCSB?
Friday night?
Come on, girl.
No, the mile deep.
Oh, I don't know
Candidates
who's
for
behind
the-
that, but there's a young man named Chami Arasange or Arasingi, or he's East Indian, and he did a very good speech last month at Astronomy on Tap, and I hired him for us.
We had a talk about that Homestead mine and the dark matter detector there with the xenon.
Yeah.
Yeah.
Yes, there's
The
xenon.
Lake of Xenon.
Yeah,
Don't know why. Well, we'll get a good.
That was quite a while ago.
yeah.
It
Maybe
was a
10
very good
years.
speech. Let's go to the night sky, Jerry.
Okay. Okay.
There it is.
Okay, now I'm trying a new method of projecting, so if any of them wash out, let me know.
Yeah, so far it's really good, Jerry.
Okay, good.
Yeah.
Oops. So this is two NGC objects, 1555. Oops, the cat stepped on my face, my pad there and changed it. 1554 and 1555. They are a form of a variable nebula that located right here in Taurus. There's the two horns of the bull, Elnath, and what's the other one?
Ooh, the other one's part of Auriga, right? I don't know.
Elnath is actually part of Auriga too.
Yeah, it's Elnath that's over on the border.
Oh,
This
that's
one's
the Auriga one.
Right. Yeah, it means the butting.
okay. So this is the bright orange star Aldebaran.
Mhm.
And right above that, about 11 o'clock at night, is rising, is the region of space we're going to look at, right below the Pleiades, Seven Sisters. Now, the thing that's interesting about these, where's my, oh, there it is. The controls are in a different place. Oops. What happened here?
I got room on my screen. You could make that larger if possible.
Yeah, let's see. There was something, I gotta
There's a
check
zoom right
this.
there, that little slider on the lower right of your window.
Yeah,
Of course, that just makes the contents bigger, not the window. There you are.
Oh yeah, much better.
okay. Now,
I got to tell you guys, we're at war with AI.
It's winning.
Yeah, I know. Took me off the screen, but just as well.
Wait a minute. Oops.
Oh, you had it there.
Somehow, yeah, somehow these are out of order here.
Whoops.
So I have to work on that. So this is the nebula. It's a variable nebula, and it is 1555. It's called Hines or Hins variable nebula. And it has a T Tauri star located in constellation of Taurus, 400 light years away. But next to it is Struve's Lost Nebula. And that would be located around in here. Let's see if I can find that slide that shows it. Yeah, there it is. Now this is rotated 50 degrees or 180 degrees from the previous one. But the green spot is the registered position of Struve's missing nebula. And the fact that it's missing is no big surprise. This is a vast collection of dark nebula. You can see this image processing is excellent, bringing out all the faint details. A lot of pictures would show this as just simply black and missing stars. But here they processed it to bring out the faint light, especially down here, where you can see the denser regions of the dark nebula. And right up in here, the dark nebula is apparently passing in front of the stars that illuminate it. And it has, when it was looked at or when it was recorded by Otto Wilhelm von Struve.
Yeah, Otto Struve.
In, do I have the date here? Anyway, 1852.
Okay.
It was a bright nebula, much like this one. But since then, it has disappeared. And that's because the clouds have moved in front of it. There's another missing object in the sky, a blinking planetary nebula. But that's an entirely different mechanism that's involved more with your eye than with the clouds going in front of it. There is another variable nebula somewhere that does change in brightness because clouds are passing in front of it. This one, 1554, has got clouds that are so dense that it simply disappears.
Really? Something that far away can obliterate and actually move within our lifetimes.
Yes.
Amazing.
So apparently this new way of displaying these things is not honoring the way I coded the order. So it's going to be a little bit of a jump around here.
There's Antares.
Yeah, this is the evening sky.
Maybe tonight? Because the moon was to the right of Antares last night.
This is on October 7th.
Yeah, okay. Oh, it's tonight.
It's tonight.
Is that how it's going to look tonight?
Yeah, I'll bet you that's right. Because the moon was to the right of Antares last night, the 6th. And Venus was out. It was just really pretty in the southwest.
And the moon is it's 9% in waxing.
Yep.
Yeah, it's waxing for sure. Yeah.
All right.
So
There it
Venus
is.
is over
There it
here in the west.
Mhm.
This is an actual, well, this is a good representation of the dusk sky. My
Yeah.
planetarium software would have this all black, but this is a better image. So the moon over the weekend was down here. Now it's moved up here, and it's going to head toward first quarter later this week.
Capricorn, really.
The what?
It's going to be going towards Capricorn.
Yeah, for first quarter, Tim.
Yeah, that's
Mhm.
past.
That sounds right.
So we have a chance here for Earthshine,
Mhm.
which is shown here.
I see the rabbit upside down, Jerry.
Now show me that rabbit.
Yeah.
So the ears are down. Chuck sees it as a basketball player.
Soccer
Oh,
soccer
okay.
player.
Yeah, a soccer
Well, you
player.
guys either have very good or very bad vision.
Oh, no, you can see the ears are pointed down.
There.
Yeah. And a few weeks ago, when the moon occulted, was it Venus, Chuck?
Saturn.
Saturn. It was in the morning. I drew a crazy cartoon of it with the little rabbit in the moon. But a Native American saw a rabbit in the moon, and it's in a lot of their pottery, things like that.
So this is an ear and this is an ear.
That's it, Jerry. Mhm.
And then this is the body of it.
Well, no, that's a sniffer. That's his little sniffer, and then the body is to the upper left.
Oh, so this
It's
is the
all
body
of
the
that,
rabbit.
It's a
Oh,
big
wow.
rabbit.
Okay.
Yeah.
Oh, wow. Okay.
You guys either have great imaginations or you're really on drugs.
Yeah.
Oh,
I
no, we
threatened
were.
I threatened Chuck that I would put my drawing in the newsletter, but I didn't do it.
Okay.
And here you can see the woman on the moon, and she's looking straight up.
That's right.
I don't.
So
see
her
that.
hair, Jerry, her hair is where the rabbit's head sort of is, and also where the rabbit's ears are. But like Chuck said, she's looking up.
Okay.
And there's
So
her
this
eye.
is her whole head here.
That's her hair.
Here, her hair,
That's-
Jerry,
And
Okay.
then come to the left. That's her
right
eye.
there. Oh, you just had her eye.
And then her nose. That's her chin where you were there.
Mhm.
That's the chin. There's her mouth and her nose and her eye. She's looking straight up.
That's it.
Okay.
But all those dark areas are mares, right? They're seas,
Yes.
Yes, that's right.
meaning the rest of it is mountains.
Pretty
It's
much.
called
Yeah, those-
highlands. Yeah.
Yeah, they're called the highlands, like Chuck says.
Mhm.
Okay. Wow. Never would have thought you could see stuff with earth
There's
shine.
Mr. Rabbit. There it is.
So there's the head and the ears.
That's it.
And that's the head or the
The nose.
The nose.
boy, he's got a
Yeah.
big nose.
Well, even as a soccer player, he's got a big nose.
Yeah.
So the only thing that's obvious to me when I look at the moon near full is the man in the moon, the face.
Mhm.
Oh,
And that took me years to learn to recognize that. So this is going to be the region where the shadows are the best, the contrast is the best, so you can get many, many features along here. One of them is the Vallis Alpus in here,
Wow. That's amazing.
which is up in here.
Mhm.
Jerry, that image right there is way better than the other, what you had been using. This is coming through really well.
Oh, good.
Yeah.
So this is Aristotle, Eudoxus, Plato, the
Mhm.
most recognizable ones on the moon.
Mhm.
And when I put the cursor on it, it shows the title of the picture. Can you see that?
Yeah.
Mhm.
Okay.
Yeah, it's neat.
I'll keep that off then.
well, what is Vallis Alpus? Is it a valley?
Yeah, valley in
Mhm.
Latin.
Yeah, Alpine Valley, Ron.
Yeah.
Okay, so that's Latin for valley is Vallis.
Well, this.
And this
Got
is
it.
Montes Alpes, which is the Alps mountain, the Alps
Mhm.
mountain. This is a standalone mountain called Piton. And it is it's a nice feature. It presents a real triangular shadow, as if it were just a pyramid there. Uh-oh, I started a conspiracy theory. So this is a close-up view from an orbiter or an Apollo spacecraft, I forget which.
Mm.
And it shows the Alpine Valley on the moon, and it shows the rift down the center of it, the fault, which is most likely a collapsed lava tube
Mhm.
or a fracture on the surface.
There are still moonquakes.
They do have moonquakes, but my impression of them is that they're mostly when something hits the moon, then you get a moonquake.
Okay, well, if that's a fault, that's from the old days when it did have tectonic activity or something, I guess.
Could be.
Uh-huh.
I don't think the moon has anything near active geology like we do. So there's no plate tectonics to build up tension and cause fault slips.
But it does have magma inside.
That is an open
Yeah.
question. I don't know.
Current view is way
down.
down there.
Way down.
Small and deep.
Yeah.
Question for Ron.
Okay.
When the moon hits your eye like a big pizza pie.
My God, I'm in love in Italian.
That's it.
Amore.
Yeah,
That's amore.
I thought that was when an eel bites your thigh as you go swimming by.
That's amore. Yeah. Variations on that, huh?
Another Whittemore witticism.
Oh, that's not, I knew that one. My little sister told me
At
that
what point did I lose control of this meeting?
I've never heard that one, Chuck.
Jerry, please take over.
10:45.
Spaceship's
This is
out of
another
control.
interesting feature at this time of the year, or at this time of this phase of the moon, is the crater Hipparchus
Mhm.
and Horrocks. Let's see. So it's never been clear to me if Hipparchus is this filled crater or this filled crater.
Mm.
Do I hear any yays or nays?
No, don't know.
Don't know. Okay.
What
I'm
is
going to
that?
guess it's the small one.
Well, it leaves, yeah, if you take it, this one as the big area, it's certainly a very old, large basin. But then it leaves this without a name. So I think you're correct. This is Hipparchus and that's Horrocks.
Well, is that unusual for a crater to get filled with something? And what would it be?
No, that's what the seas are. Over here, Sinus Media, the middle bay
Mhm.
is a depression that got filled in.
Solidified lava that was smooth.
Yeah, filled in by lava from below. And here's one here. This is a crater, a very old crater that has been filled in with a flat surface. So there was a lot of liquid involved there. When these things hit, there's a lot of energy release. Of course, the impactor has kinetic energy up the wazoo. And the moon is very massive, and there's a lot of energy release, and both the impactor and the region it hits become liquid for a short time. That energy goes into melting it. So there's a lot of lava and opportunity for large craters to fill in.
Jerry, the caption to this photo says that Horrocks lies entirely within the rim of Hipparchus. So that implies it's the bigger area.
Okay.
Oh, yeah.
Okay.
Well, has modern man ever taken a picture of such a strike happening?
Just small ones.
Yeah, not close up, but every now and then amateurs are taking videos of the moon and they get a little bright flash of light. And then a spacecraft will go back to the area and there's a new small crater. Sometimes the craters are too small to really notice, but
Yeah.
The closest thing we've seen is that Shoemaker Levy 9 hitting Jupiter, but it wasn't a solid body it was hitting.
Right. And there's a story I kind of remember about monks having witnessed a crash on the moon, like in the 1200s or 1300s. You know that one, Chuck?
Yeah.
Yeah, that story.
There was a Sky Telescope article about that many years ago.
Yeah.
And I think they still argue back and forth about what it was, but it's potential.
And Carl Sagan may have mentioned that in one of his Cosmos issues.
Mm-hmm.
Well, I Googled Hipparchus, and it shows a picture of it right next to Albatignius.
Huh.
Just about 20% larger than Albatignius.
So they may not know either.
Any of you fellows know the status of our recent visiting mini moon? Is it orbiting us or moon or both, or
Us?
it's just out there in a big orbit?
It's orbiting our system.
Yeah.
Is that out, you think, as far as the Webb telescope? That's 1,000,000 miles.
No.
And Jerry wrote a nice article for the current issue, a newsletter about that.
I don't remember that, but I'll take
I
the
don't
credit.
either.
I printed that. I put it together.
Yeah. Oh, I believe you.
And Chuck checked it.
Fact checking.
No, I mean he proofreads because otherwise the newsletter would be pretty terrible. If we didn't have Chuck.
And spell checker.
Okay.
So it's
Now we're
coming
back to-
soon. It's coming soon.
Comet T.
Mhm.
This is a slide we borrowed from last week. It shows
Yeah.
the progress on the
Yeah.
sky chart. As
Yeah,
it
that's a
travels.
morning shot, Jerry, right?
You
Is
what?
that would be a morning shot, morning prediction.
This is not a prediction like that. This is just against the celestial sphere.
Yeah,
It's not looking any particular way
yeah. Never
because
got it.
this
Yeah,
is
never.
this is in the morning and this
Yes.
is in the evening.
Okay. Okay. Yeah, I never
So
caught
here
it.
we are
Jerry.
at this is October 14. This is the point where it's closest to Earth and therefore the brightest, I guess, right around this time
I
period.
think, yeah, I think it's the 12th, but close enough.
Okay, so 12th would be right there.
Yeah.
Yeah, that would be Saturday evening then. Huh?
Okay. So it should be, it's in Virgo and it should be in a late dusk, if not absolute darkness.
Yeah, I looked that up this morning. I think it's going to be down in the muck in the west on our star party.
Yeah, you need a good horizon, Tim, for that.
Yeah, I don't think there's a chance.
And the 12th for us is, that's already the 13th. It'll be up a little higher, 13th UTC, which this might be done in.
Oh, okay.
Does it have just one tail?
I'm glad you asked that.
Really?
These are not photographs of the comet. These are graphics to show the position of things. October 12, 13, 14, 15. Arcturus is up here. This is looking southwest, west, shows the relative height above an idealized flat, like an ocean thing to the west. Unfortunately, our ocean here is to the south, not the west. So the west is where the rockets go up from Vandenberg Space Force Base.
Yeah.
So Venus will do some minor planetary motion here. And Grapheus star there, Shuba there, and Antares, faint orange star shown here.
So that's really good spotter, Jerry. So if people have a good horizon, they look kind of halfway between Arcturus and Venus, that's where your comet's going to be.
Yeah, it's a good hopping.
That's a Tim star hop.
Yeah.
Yeah, I really like what you just said. I didn't know that.
Yeah.
And this is 45 minutes after sunset. The sky will not be this, well.
It'll be a little glowy.
Yeah.
Yeah, and we won't even be starting our star party till 8. So
okay.
Yeah.
Huh.
Oh,
Where
really?
if you were to superimpose our mountain range on that picture, would it block out the comet?
From my
45?
house,
I don't think
mountain range
so.
comes down like this, so I might get a chance at it. It's
Because when the
fog that gets me
Vandenberg
here, not the
launches, for
mountains.
me, it's north of, where I could see a good view. There's mountains in the way.
yeah.
Yeah.
Yeah. So from here,
Okay,
I'm
this
just
is a
looking
recent
straight
photo.
west. Wow.
It's got two tails.
Aha. And now why is that? Why isn't there just one pointing away from the sun?
One is an ion tail and one is a dust tail. And the ion tail pretty much is the solar wind driving it. The dust tail also has a big gravitational effect as just the trajectory of the particles.
Yeah, the
No,
dust.
it's in the orbit of the comet.
Yeah.
Yes.
I
This
can
is
remember.
it's defining future meteor showers.
Yeah.
Oh, okay. And it's on its way out. It's gone around the sun.
Yes.
Yes.
It's past its closest point to the sun. Now it's coming up on our closest point to us.
Yeah.
So all comets have two tails, sometimes three. They never overlap, and
They don't have 3.
they don't have three. It's just two. One's ions, and I can remember in high school or maybe even younger, a science teacher saying, comets have a tail always pointing away from the sun,
Yeah.
and we don't know why that is. And I
So
would
maybe he didn't know.
Yeah, Ron, if somebody claims a third tail, you can tell them that's a tall tail.
Well, sometimes there appears to be a third tail or an anti-tail, but it's just your perspective on the tails.
Yeah.
Especially if it's a thin fan-shaped tail. Yeah.
Yeah.
Well, do they have rocks that are like asteroids, which were former comets but lost all their water
Yes.
over the years? And we just can't see them because there's no tail, but they come in just like an asteroid. Do they become an asteroid? Asteroids are former comets, aren't
Oh,
they?
how
It's
pretty.
fuzzy, Ron. And asteroids are not former comets, but necessarily.
Okay, but some of those rocks got water in them and others didn't. I wonder why that is.
Depends on their history, where they came from.
Mhm.
You can never escape your neighborhood. So this is a photograph outside of Syracuse on the Sicilian coast
Oh, okay.
of the comet. Did I put down September 29?
Huh.
So it'd be a morning shot, huh, Jerry?
Yeah, these are all morning shots.
Yeah.
This is taken from Lick Observatory up
Oh.
in San Jose
Hmm.
on September 28. It's a 10-second tracked exposure.
Okay.
And the final one for this showing is
Wow.
from, I believe this is from, yeah, it's from Chile,
Wow.
Oh,
San Pedro de Atacama in Chile.
Hmm.
Nikon D750.
With chili spelled wrong.
Like chili pepper.
Yeah.
Where's that?
In the caption when you put your
Caption?
cursor on
I
there.
think that's the Spanish spelling.
No.
No,
No.
no, the
No.
country's Chile.
Yeah.
Yeah.
Chile.
There's also either a satellite or a meteor up top too, if you
Yes.
You see that? Yeah.
Yeah.
Yeah. I
Most
just got
likely
the weather
satellite, I guess.
report. I just got
Thank
the
you,
weather.
Elon.
Yeah, I got the weather report from there. Chile today, hot tamale.
Hot tamale.
Okay.
Okay, now we just discovered a exoplanet
Mhm.
around Barnard's star in this
Wow.
position here. And Barnard's star is either the fastest or one of the fastest stars in proper motion in our skies. It moves noticeably year to year if you
Yes.
follow it telescopically. And it's near to us. It's only 6 light years away. Our nearest star is four and a quarter or something like that, 4.5. This is a red, it's the most common kind of star. It's a red dwarf.
Hmm.
And the star has the imaginative name of Barnard B.
Yeah, named after E. Barnard.
Mhm.
And that exoplanet is in that wonderful zone around it.
It's not in the Goldilocks zone, I don't think.
So
But it is the star is fairly cool. It's about 4,000 degrees, 4,500 degrees
Hmm.
Fahrenheit. Our sun is 5,800 or yeah, 5,800 degrees Kelvin.
Kelvins, yeah.
Oh, this is 4,500 yeah,
Fahrenheit.
2,500 Celsius. So it's much cooler than the sun. The planet, the exoplanet, is very close, and it's probably too hot to have any kind of chance of life on it. But they're looking for now, with better instruments, they're looking for this, by the way, has been labeled as a super Mars. They're looking for now for a super Earth or an Earth-like planet that's farther out.
I have some images from about 10 years ago showing the motion of Barnard's star.
Okay, you got it
pretty
ready?
Yeah. Let's see. Here is I wonder if I can show both. This is the Palomar survey plate. See if I can show both. No, I can't. Okay, here's the Palomar survey plate showing where it was in 1950.
Okay.
And let's see if I can
superimpose the two.
if I can add another one. No, it doesn't look like I can. Okay, and that kind of defeats the whole purpose, because if I show,
Well, which
because otherwise I could show, you could see the motion.
Yeah, need a reference, Chuck.
Yeah. Here's the Oh boy. Let's see.
You suppose it was the Webb that discovered this XO around Barnard's?
No.
It
Hmm.
was-
Here it is. Here it is in 2013.
And is the X where it was in 1950?
The X is where it was in 1950
Okay.
Wow.
against the same background stars, of course. Anyway,
So if you remember this position, commit it to memory. I'll show you a picture where it is today.
okay, fire it up.
See, how do I get back into?
You could do time
Okay,
lapse,
good. I got it.
time lapse photography, one shot a year, and you'd see the damn thing move, wouldn't you?
Yes.
Yes, you would. Mhm.
And so anyway, this is that. And then this is a direct picture,
Mhm.
oops, of the red star. This down here, that red star, that's Barnard's star.
Okay.
And that is dead center in the picture here. So if you remember where Chuck had it, it's moved.
Well,
And
Jerry, where is this star in relation to Proxima and Alpha Centauri?
Seems near Ophiuchus, isn't it?
Yeah.
Are they both in the
Yeah,
same
there's
direction?
yeah,
there's several rise, so that's upper Ophiuchus. That's the head of the serpent bear Ras Al Haig.
Yeah.
Ross's head in Arabic.
yeah, this is a northern constellation. Centaurus, where Alpha is a southern constellation.
Mm-hmm.
So they're not anywhere near them in terms of an angle on the sky, but it's close to it in absolute distance because this star is about 6 light years away, and Alpha Centauri's or Proxima Centauri is about 4.5.
Mm-hmm.
Another thing is Aquila is off to the left here, so you can see that.
Yes.
Yeah,
Mm-hmm.
there's Altair up there.
Yeah.
Mm-hmm.
This is where my planetarium software superimposes plates. This is an artist rendition
Wow.
of the,
Oh, there's where we need Sprach Zarathustra.
yeah, but this shows how big the star would look from the position of the planet.
Mm-hmm.
And so there's no absolute frame of reference here, so it doesn't really mean very much, except that it's not a pinpoint.
Hmm. But it's
Now,
not a gas.
last week, go ahead.
It's not a gas planet though, in that close. It's a rocky.
Yeah,
So-
that's why they call it a super Mars.
Mm.
So bigger, as big as Mars or smaller than us?
Super means slightly bigger than Mars, but less than Earth.
Oh, okay.
They have the one that transition that gets me is they have super Earths and then they have dwarf Neptunes.
Yeah.
So that's kind of depends on which way you approach it from.
Mm.
And they do have gas giants going around, big blazing hot stars real
They
close.
do, and some of these gas giants are in orbits of a few days, so they're really close.
How in the world do they keep from burning away all the gas?
I don't think they do. I think there's just still enough gas left to go.
Oh,
It doesn't burn, Ron. It just gets ablated away.
Yeah, it gets blown away.
yeah, pretty much like the atmosphere that Mars used to have, right?
Yeah.
Or Mercury used to have.
Mercury had, okay. Wow.
So Jerry,
Okay.
did they discover this from transit?
No, I think
Well,
they got this from gravitational wobble. So radio.
Oh my
probably
gosh,
radio
really?
cross.
Oh, okay. Wow.
Well, this is lensing we're looking at here, isn't it?
This
Mhm.
is lensing. It is, we did a bit of discussion the last week or the last 2 weeks about Hubble tension. We have the 2 different methods of determining the Hubble constant or the Hubble parameter now.
There's
Yeah.
like 3 or 4 actually, but
Okay. And so but they're coming down to 2 different values. And depending on the different techniques that they use to measure them, and it's all to measure distance. And the distance measurement is the big uncertainty and the source, many believe, of the difference between the 2. This one is a third method that does not rely on any other method to determine the distance to the object. It gives the distance to the object, and it's looking for what type 1a supernovas that are being lensed in a galaxy. So this is the galaxy that's doing the lensing here.
Mhm.
And this orange thing is a redshifted galaxy that's being lensed. So this is a galaxy that's distorted by
Mhm.
spherical aberration, probably, to this shape.
Yeah.
And that shape, there's another one over there being lensed by this.
Mhm.
And these are the same supernova seen in this galaxy.
Wow.
So these show up at different times.
Yeah.
And of course, once you see them all, you can't see the onset. But type 1a supernovas have a very characteristic decay curve or light curve. And so you can determine where these are on their light curves, and you can determine the time difference that you see there. And from that, you can get the distance to this galaxy or to these objects. So this is the method of measuring the Hubble parameter and the distance at the same time. And this gives, oops, there. This is the tension, which is disagreement between several methods, Spitzer and Hubble data. And here's the Planck data recently. This one from the lensing, it's not as tight a measurement yet, but it gives something that's partway between the two.
Well,
It agrees.
yeah.
It agrees within the error bars with this method.
Well, those are both the same method, really. Those are both using the cosmic microwave background.
These are?
Yeah.
Okay.
And there's new methods now using these red giant branch stars and things, and they are all converging toward overlapping values. And the only ones that don't seem to converge are ones that have to do with type 1a supernovae, like this one does.
Mm-hmm.
And so they're thinking there's something systematically wrong with our understanding of type 1a supernovae. So
could be
the tension might be going away from that. And that seems to be more recent than this, although this says 2024 also.
But that galaxy that was being lensed just happened to have not one, not two, but three supernovas going on at once.
It was the same supernova.
Right.
But there are three images of the galaxy there.
Oh, the galaxy didn't become a big long arc. It's three versions or several versions.
That's the distorted view, and it's a funhouse view, and there are three images of the same galaxy there, but the light traveled on different paths.
Yeah, that's
from
it.
each of those images, and so the timing is different on each of them.
Right.
Do they ever get lensing from around a closer galaxy that's a virtual ring?
Yes, Einstein rings.
They get nice ones. There's a lot of imaging up or lensing up there. You're right. This is the early WMAP 2012. The value they're quoting goes between 70 from this new method, from 70 to 83, which is off scale. They didn't chart it on this one.
Yeah.
On this plot, but it disagrees with all of these values.
Okay, so what one or both or all three of those different
So
views
it's still under tension.
Okay, got it.
So the conclusion of this is Hubble tension is very real. This supernova is referred to as H0PE, but if you look at it, it seems to spell hope.
Yeah.
H-O-P-E.
Yeah. That's the name of their measurement mission is
right.
Yeah. And actually the fact that their error bars overlap is saying, well, the tension might not be real. We just have to figure out what the real measurement is.
Yes.
So we'll always know there's a lensed, gravitationally lensed a galaxy back there, but we'll never be able to see what it really looked like.
Okay, consider this. Somewhere out there in the region of this lensed galaxy, there's an astronomer that's looking at our lens to galaxy.
Yeah.
And it's like seeing us in a hall of mirrors, right?
Yeah.
I got it.
Kind of.
Uh-oh.
Oh,
Call AAA to Mars.
Yeah.
Yeah, it looks like they hit a pothole. They must have driven through Goleta here.
That's rubber we're looking at. It's rubber? I thought they made them of metal.
No, this
It is
is
metal.
metal.
Oh, it's really?
I think this is aluminum or titanium.
Hmm.
Now, one of them had holes purposely left in it. That wasn't this one, I don't think, but they spelled out in Morse code. They spelled out JPL. What
Hmm.
happens with these systems is that the NASA lets a contract to an agency like JPL with a mission statement, and then they design software and they break, or not software, but they define the parameters of their instrument, and then they meet out to different companies, different subunits of that, and then the integration house, as they call it, will integrate the whole system back together. But you go out to all these different places, and Santa Barbara Research Center, where I worked, was one of the component providers at the very lowest level. And so we would always put in our, we'd etch into our chips SBRCs, so it couldn't be denied as a, advertising thing, although no one ever sees it, although someone did once. But they do that, and then when it goes up, every company adds their logo to the next stage as they hand it on. NASA has a habit, NASA has a habit of peeling all those labels off and putting on their NASA. And so JPL didn't like that, so they encoded JPL into the wheels with Morse code, missing part of the radius.
Hmm.
And so that stood out very well. They got it through, and it wasn't until it was on Mars that anyone realized that that's what was going on. So
And Caltech, at least, they administer, I think, JPL. I know whenever Caltech made some of the instrumentation or some hardware device, they would etch DEI into it for danger, electrical insulator.
Well, are you saying that those logos they've stenciled on the tires are the reason for this?
No.
no, this
Oh.
is due to damage. This is road damage.
Road damage with a lighter gravity.
Yeah,
And they're metal tires.
they're titanium tires, very tough. Now,
God.
there was a case back in the Desert Storm era where when we invaded Iraq to get them out of Kuwait,
Right.
captured some night vision devices from the Iraqi army, and we got them sent back to us at SBRC because they had SBRC labels on the chips. And that was forbidden. We were not allowed to sell to them. So they had to trace back how the Iraqis got them in their instruments. And it turned out a Dutch company named Delft had broken their agreement or had been conned into selling the contraband. But it was a nervous time for a while. We're all going, we didn't sell that to them. So anyway, this is all torn apart from probably going through a rocky field with pointed things. This is just one tire. It has 6 wheels, 6 tires. This is the other one, the other picture, same damage, same tire. So out of the six on here, just the middle one on the right side, this looks like it fell on something. So, but the rover weighs a ton, and it's going over this rough terrain.
Huh.
This is the back end. This is the front end. The right tire is this guy over here in the middle. But this is a Curiosity self-portrait.
Well, since we know it's electrical, do you suppose there's some similarities in its drive mechanism with the 2 vehicles that you and Chuck drive?
At some level.
Well, it's run by electric motors on each axle.
On each
This would
axle,
be
not on
a,
each wheel.
this would be a 6 motor. My Tesla's a 2 motor.
right? That's how trains run, aren't they? Big locomotives?
Yeah,
Trains?
sort of.
Yeah, trains have traction motors on the axles and they have a diesel generator inside to supply the electricity to run the traction motor. So there's no gear shift, there's no drive shaft. It's just electrical cables.
But the levitating ones that are all magnetized are coming, aren't they? Someday.
Maglev, I
I
think the
guess, yeah.
Japanese are getting that to work. They have a demonstration, I think.
Yeah, they have I think a working one.
Yeah.
Do they work on regular rails? Do we have to replace the tracks?
You need special tracks.
Yeah.
Oh, you need special tracks. Okay.
Now, the US has been experimenting with a sophisticated, what is it, support system so that you can run a high-speed train on same old freight track that gets beat up by our freight trains, but I'm not so sure that's been working out.
Tough problem.
Yeah.
Well, there can't be a lot of wear and tear on the metal that doesn't touch anything.
No, it's contacts. It's a contact sport going around on Mars.
But it's still running and not going to be shut. Well, actually, it's way outlived its time, hasn't it? By
I
about
don't
10
think they
years.
put much of a limit on this one.
No. Now this one does not have any solar cells. So the dust covers it, but it doesn't cut down the power rating of it. There's a nuclear reactor of sorts back here on the back end, sticking up in the air like a bug with its butt up in the air, its stinger up. So it has a radioisotope in there and the thing gets hot. And there's a gradient, a temperature gradient across this, and it has thermocouples that create electricity based on the temperature difference it senses between two contacts on the thermocouple. And that's where it gets its electricity from. So the lifetime of those radioisotopes is on the order of decades.
Wow. But this is earlier than the one that came with a helicopter. The Ingenuity shut down on the, this is
Yeah, this
Curiosity.
did not have a helicopter.
Yeah, this is Curiosity. What's the name of the one that had the helicopter? The
Perseverance.
that's right.
Now,
Ingenuity.
Perseverance is going around on Mars and it's taking samples and it's putting them in these little glass bottles and then leaving them somewhere to be picked up later. I always wondered why they didn't just store it in a rack on Perseverance. Because then you can find all of them. You don't have to hunt around for where they got dropped. They're little things and dust might blow over them. You might not be able to find them.
It's an adult Easter egg hunt.
Yeah. And originally they had a whole plan to go with a little rover that would collect them and bring them back to a central rocket station, and send them back to the Earth. But now they had such success with the helicopter that they sort of just canceled that whole project. And now they're talking about having a little helicopter go and catch them.
Yeah. And then they're also talking about canceling that mission because of expense, but that's another story.
Wow.
Okay.
That's the final one. And we still got 6-7 minutes, gentlemen.
Okay. What do you want to talk about?
When they say two motors in the on the Tesla, and this one was a 6 motor. I mean, the two motors are in the wheels on a Tesla?
No, they're on the axles.
Yeah.
Differential.
Just each axle, front axle, back axle?
Yeah.
Oh, okay.
You can go 0 to 60 in about what, 3 seconds?
Probably in a model, which model is that? Model S or Model X? Yeah.
Oh,
Well, I think our Tesla Y has got 3.4 seconds to 0 to 60.
Good grief. You might as well get a
it's
I know,
definitely an acceleration experience.
I tested it one time when there was no other traffic around. It scared me.
Yeah.
Wow.
It's
The first time I got on the freeway, it's like, oops, I'm doing 80, gotta slow down.
Yeah, it runs so smooth. I put it on cruise control and stick with that. Otherwise, I get too tired and start speeding up.
Our mechanic is worried about those because it's going to put them out of business. There's no work to do on them.
Yeah.
Not
Really?
much. The owner's manual says that you have to change the windshield wipers every 4 years.
Yeah.
And rotate the
Pretty
tires.
much, yeah, and the tires are the only maintenance, and keeping your window washer filled.
Yeah.
I hope they don't just, I don't know. I think it's a mistake to go all electric in California. I really do. I think that's a crazy idea.
I can't hear your voice.
I think it's a crazy idea to go all electric in
I
California.
don't think that that's probably going to happen myself,
I hope
but I
not.
think that electrics is going to be a major player.
Yeah.
You got to cut down on the CO2.
Yeah.
You just push it someplace else. You still got to generate the electricity.
Oh, come on, Bruce. We've been through that before. You generate it at places that are more efficient if you still have to use the frickin' carbon sources. But you go to solar and it's essentially free and you don't care about any losses in transmission or anything like that.
I read a news article that the UK is now, or the UK is now running 100% petroleum free for their energy.
Well,
They get it
coal
all
free.
from,
Coal free is what it
wind.
was.
What's that?
Coal free.
Coal free. Okay, coal.
They don't
free.
use coal, but I think they still might have some natural gas.
Yeah, they have the North Sea oil they don't want to lose. But
back to astronomy. At about 2:00 tomorrow morning, Hyperion, that one weird little satellite of Saturn that looks like a sponge and has chaotic rotation, is going to occult a star.
Oh,
So I'm going to be up trying to get away from the marine layer to see if I can catch
good
that.
luck.
Oh, Chuck, what do you think about Saturday? Are we going to have this? I've heard that this fog is going to stick around till at least Thursday.
I always don't trust any of those predictions until the day before.
Yeah.
Or even the day of. It's just the fog. The marine layer is so tough for them to predict, it seems.
It's been really thick. It's been really thick.
The National Weather Service has been doing better on that. I noticed that on my normal predictions that I get from them, when you go to look at what the cloud level is going to be and stuff like that, they don't include fog unless you specifically ask for it.
Oh.
And lately they've been doing pretty good.
Good. That's
things
good.
like astrospheric and the sky chart are not good for the marine layer at all.
No.
They don't show it, but we sure see it.
Yeah.
Yeah, KYT has, what is it, the new weather alert or something like that, first alert, and you can go to a live radar that has futurecast, and some of that is okay, but for some of the stuff we did up at Refugio or Bacara, it just wasn't 100% accurate.
Yeah, the National Weather Service has a loop animation of the satellite pictures.
Yeah.
And if you watch that, you can get some idea of how it's moving anyway. So you can see if there's a clearing trend coming your way.
Yeah, that's probably the best bet right there. So.
And there are the mountain webcams too. So you can go to those and they look down on the coast and you can see what's covered. Or you can see if you go up on West Camino Cielo, you can tell if that's going to be clear up there.
Now what do we search for? It's just webcam.
Do Santa Barbara mountain webcams or alertcalifornia.org.
Alertcalifornia.org.
Yeah.
Okay.
They have a whole set up and down the whole state. I mean, just tons of them. And then you can zoom in and select the ones you want to look at.
Okay, I'll try that.
Listen, gentlemen, since we're down to the wire here, tomorrow night we got not one but two things, don't we? We got the workshop online,
right?
And Camino Real.
Telescope Tuesday at Camino Real Marketplace. Yeah.
If the fog lifts.
Okay.
And the telescope workshop on Zoom.
Are you going to be on? Okay.
Ron mentioned that first, actually.
Oh, did he? I thought he mentioned Telescope Tuesday and then Camino Real.
Well, Camino Real is Telescope
Oh,
Tuesday.
that's right.
Yeah.
One's online. You never thought of moving them apart so we could get the same.
Okay, I clearly, after today's session, I clearly need more coffee.
Just for a little fast update, I still am not able to do live chat on my computer. I tried my cell phone and I couldn't do it there either. But we have 4 people watching right now on the Zoom on YouTube, our YouTube channel. I'm really apologize to the people watching that I cannot communicate with you. I wish I could.
Well, can you hear me, let's see, Tom and Tim.
Yeah.
All right, what you missed that might be new in your life Friday night with a well-dressed young undergrad that gave a talk about a light dark matter experiment out at the university. Guess what? There's a new particle called the dark photon. I'm not going to say any more than that, but it was portrayed on stage, the dark photon. I don't know what it means, a photon that doesn't have light in it.
Ron, yeah, you're taking these things way too literally. Dark just means unknown.
Oh,
They're calling it a photon because it's kind of a mediator of this interaction with this particle. So don't take it that literally.
all right.
Well, you do have to use sunglasses to see them.
Yeah.
Sunglasses.
But once in a great while, Jerry does call up light as a topic, and I'm fascinated by it. And Chuck sent me an article that I can't believe that we could throw in if you felt like it. If you want to get it sent to you, just give him a shout out on email, and we'll.
It was one of these weird quantum experiments where they shine light into suspended cesium atoms or something like that, and you see the excitation. And they said from the distribution of how things came out at the other end, they see evidence of negative time.
Negative.
Yes, that's a unwarranted extrapolation of the
Yeah.
data. They're not seeing that if the extrapolated, the negative time light is actually the normal time light, and all the rest of the light is retarded time light.
Well,
One of the few cases you can say the word retarded nowadays.
yeah, no, this is a little different. They're just saying that the quantum state is kind of smeared out, and there's an early time and a late time. And anyway,
That's relatively right, but
yeah,
negative time is not warranted.
yeah.
Let's do it again next Monday morning, gentlemen. We'll
Sounds
see
good.
the different events, and thank you. Take care of your lovely wives, and we'll see you, I guess, at the planning meeting or tomorrow night's workshop or Camino Real. That's
Okay.
it.
Thanks, Invisible Ronnie.
Bye, everyone.